Hello everyone. So in this video, we are going to extend our knowledge from previous video, and we are going to dive into decorators. So decorators are something which is applied on functions, and by that the functions gains a lot of functionality, and it can do a lot of other things which normal function cannot do. So in previous video, you can check it out on my channel. We talked about only certain properties which you can do explicitly in Python, properties of functions. But today we are going to talk about some functionalities, some decoders of function with which we can do a lot more than a normal function can do. So for example, there's a library called functools. So let's import it. LRU cache. Right, so LRU cache is a function inside this library functools. So now let's just create a function which is suppose complexer, right? And you have, we are inside this body, we are writing this body, and now suppose I have given two parameters and I'm saying that print hi, print hello, print bye, right? So like it's a very small function which has 3 lines of code, which is printing, printing and printing, right? Hi, hello and bye. So but at the end it will return a plus b, right? So this is a small function, and now if I have to call this out, right? So suppose suppose I have this and I am calling it like complexer a comma b, and now I am printing, right? So if I run this, so I have to put real numbers. So yeah, you can see first, like if we are the interpreter is encountering this number, then it will first call this function complexer hi, hello and bye will print, and then whatever the return value is, a will store it, and then we are printing a, and that's why we are getting 5 at the last, right? So but like this is very memory inefficient. Why I'm saying that? Because let's say we have 100 lines of codes, or 1 million or 10 million or maybe even more lines of code like in the body, right? So every time when I'm doing this, like every time suppose I've called it again complexer, right? And this time I'm doing 3,4. So every time when I'm calling this function, all this 10 millions line and all the lines are getting executed, right? So it is very memory inefficient, because memory is like the resource is being utilized again and again whenever we are calling this function, and like we have to, so like we do not have any choice, right? We have to call all the print functions, we have to execute all the intermediate lines of code in this function. But what if I am having again a variable c and I've called 2,3. Now in this case, just imagine that you have called this complexer with 2,3, and whatever like high is this line of code is executing, then we are getting 5, right? But when we are calling again this complexer function, and this time we are saving the return value to c variable, the same function is executed, the same thing is going to happen, right? So for the same set of arguments or for the same set of parameters, why are we doing the same thing, right? So in this case we will say that it is memory inefficient, right? So what we need to do, we need a cache memory where like we can store things, like already we have encountered 2,3, so we do not have to execute these 3 intermediate lines. Or if we have 10 million lines, then you can say we do not have to execute 10 million lines, right? So here comes the power of decoders. So LRU cache, if we do this, so this is the denotion that we are using this LRU function, and we are using this as a decorator to this function complexer, right? So now if we print it, right, so first, like let's comment it out. Now if I've printed b and then I've printed c, what we will get? We will get c. So hi, hello, bye, right? Hi, hello, bye and hi, hello, bye. Like so these 3 lines code of hi, hello, bye is executed 3 times, because a, b, c, there are 3 variables and 3 of them are calling complexer, so that's why hi, hello, bye is 3 times, right? But then we are printing ABC, so we are getting 575, right? So now we have uncommented this. Now let's run it. So now let's see hi hello bye and hi hello bye. So this time we get hi hello bye only 2 times, because for A we are executing these lines, for B we are executing this line, but for C the interpreter looks that okay, we have already stored a result in the cache where you have already passed 2,3 once, so we will use the same output without executing the intermediate lines, right? So that's why we will get 575, but we will not get the hi hello bye intermediate statements, right? So this is very memory efficient. So this can be useful when we are dealing with deep learning models or machine learning models, where memory sometimes is a very important factor, because many times Colab gets timed out because of memory limit. So this was one of the power, you could say, for using decorators, right? So these are decorators, right? So decorators, like in this case, like LRU cache is a function, right? But why are we saying decorators then? So decorators is just a fancy term, right? So decorator enhances the functionality of existing function, right? So it takes the function from its normal state to a higher state. It's just like that. But LRU cache is already a function, right? But adding a @ sign will will indicate that okay, compiler, you have to treat this LRU cache as a decorator to this complexer, right? So this was the basics of what decorators are. So now let's look at one more example, and then we will move towards more complex decorators like data class, static methods, right? Class methods. These are some advanced, you could say, decorators. But I'll give one more example. So let's first comment it out. Okay, so let's do one thing. Let's create a complexer function again, and now let's have this function parameter, right? And now again we have another function defined inside this function. So this I've explained in the previous video. These are some properties of function, why it differentiates, why the function Python functions are differentiators with other language functions, right? Like C, C++, or Java, right? You can check it out on my channel also. So a comma b, I've given it to this function, and now what I'm doing is I am adding 1 to a, I'm subtracting 1 from b, and I'm returning a into b, right? And now I'm again returning simpler. So let's do one thing. Let's create one more function. Let's say trick. Okay, and let's give this trick function 2 parameters, and let's say we are going to return a into, right? So let's say that okay, this is function a comma b, right? So like this, right? And we'll say that okay, simpler, we are returning simpler of we are returning simpler. All right, okay. So now if I want to print it, right, so I have to call complexer, right? So let's say I have called complexer, so I have to give a function, right? So let that function be trick function. I just have to include the name. I've told you in the previous video also, right? And what am I doing is I'm calling this function and I'm putting the argument as print function, and this whole thing is going to return me a simpler, right? But I have to call the simpler also, right? And for that I have to again give the simpler parameters. So the a and b of the simpler parameters will be fed here now, 2, 3, right? So now if I'm going to run, what will I get? So 2 is getting updated, incremented by 1, so we will get a is 3 from this line, and then b, which is 3 right now, will get decremented by 1, so b will be 2. So a is 3 and b is 2 now, right? So and if we are returning it, we are actually returning the multiplication. So 3 comma 2 will be 6, so we'll be getting 6, right? Is not defined. Okay, let's run one more time. A is not defined. All right, not defined. Why is this error appearing? Okay, all right, I don't know why we are getting 6, right? So this, right, as I told you. So now, so this is a very tedious work to do, right? So we have to call complexer, but we are also giving trig function, and then we are explicitly giving 2 comma 3. This is very you could say code inefficient. I would not say memory efficient, but code inefficient. Like if someone is going to read your code, then it will be like very confusing. So what we do, we'll use the power of decorators, right? So as I said, in the above case, we use LRU cache decorator, right? But LRU cache is itself a function. So what we will do, we are going to give this trig function a decorator, right? So what we are doing is, okay, so just a second. So we need to copy this whole code and we need to put it down. Why I'm doing this, I'll tell you in a second. But right now we are just saying that we are considering this trig function, and we are saying that put this into a decorator, right? So like for example, the function that we are giving, right? So we are explicitly putting a function to a function, right? So rather than doing that, our trick is that the function that you are putting inside, you just set a decorator of the higher order function. So just one quick recap. When we previously did this line of code, right? So I basically told you that we are passing a function, right? So the function that we are passing is known as callback function, right? So function here is a callback function, and the complexer that you are seeing is called as a higher order function, right? So I was saying that you just need to put the higher order function with a decorator, right? And you need to set this decorator to the callback function, right? So this is the trick, right? So I'm just saying that whenever we need to call complexer and we need to give a function, just write decorator of that higher order function to that callback function, right? So rather than explicitly mentioning complexer, you just need to mention trick, and you just mention 2 comma 5, right? So this is now trick is not a normal function. If this would have been a normal function, so let's see, see 12 and then 10. So if this would have been a normal function, we would have get just a second now, right? So if this is a normal function right now, so we are getting 10, right? Because 2 into 5 is getting 10. But if we do this, we are saying that this is a callback function and this is your higher order function, and rather than explicitly calling complexer trig 2 comma 5, you just give trig 2 comma 5. It is very well understood by the interpreter that you are trying to call trig, but it is of decorator complexer, so it will directly call this function. Rather than calling this function, it will call this function and it will put your function value as your trig. It will do your job, right? So it is code efficient right now. It is not memory efficient, it is code efficient in this case, right? So okay. So now if we print it, see, you're getting 12 and 12 right now. So rather than getting 10, you're getting 12 and 12. So this is the power of decorators. So in the above code also, if you are observing well, so this LRU is basically a higher order function and your complexer is a callback function, right? So this is the power of decorators. And now so this was the case of this was explicitly the case of, I'd say memory efficient use case application of decorator, right? And this is an example of code efficient application of decorators, right? So I gave you two very important and very unique example corresponding to code efficient and memory efficient, one using functools library and one using a normal right, a higher order and callback function. So I just end this video right now, and yeah, feel free to comment, feel free to like, share, right, subscribe, right. Okay, thank you guys for watching this video.